S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Now we studied the interference of light by the division of wavefront and by the division of amplitude. Now what kind of the fringes are formed, whether they are bright fringes or the dark fringes. So that will be understood by using the Young's double slit experiments. So myself Narendra Kaur, let us start how the interference pattern looks on the screen. If you want to study this topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now Young's double slit experiment. So now from its name, firstly it is discovered by Young's. Then what is the meaning of double slit? So in this case we have understand what is the interference. We know that for the interference 2 coherent sources are needed. So minimum 2 coherent sources are needed here. So that's why we are using here double slit. So instead of single slit, double slit is used. So this is the meaning of double slit. That means in order to produce the coherent sources from the single source, the double slit is used in this case. Now this is called the Young's double slit experiment. So in this case we are using the 2 coherent sources of light which are placed at a very small distance. The distance between these 2 sources, that is very small, that is d. So they are far apart by small distance d, and there is a screen which is at distance capital D from the 2 sources. So the distance between the 2 sources or the double slit and the screen, that will be capital D. Now we know that the interference pattern, the light from these 2 sources, they will come out, and then the light wavelets, we know that according to Huygens principle, the each light or each wavefront, that will act as a source of secondary wavelets. Then these secondary wavelets, they will superimpose on each other. After the superposition, we will get interference pattern on the screen which is at the capital distance d away from here. Now in this case, here firstly this is the S source, the point source. Now from the point source S, the light is originating and it is travel in the forward direction. We know that here in this case, so there are secondary wavelets or the wavefronts are generating from the source S. Then these wavelets fall on this double slit. So again at this slit S1 and this is a slit S2. So from slit S1 and S2, these wavefronts or the wavelets, they will pass. So here the frequency of these 2 wavelets, that will be same. So this is the main first, or you can say that this is the first condition for the coherent sources. That means for the coherent sources, the frequency of both the sources, that will be same, and also its wavelength, that will be same. So here in this case, the light or wavefronts, they are originating from the single source, and after that there are, here we are using a 2 slits. So these 2 slits which are separated by a small distance d. Then again these same secondary wavelets, they are passing from these 2 slits. So the wavefront for these, from S1 and S2, this wavefront, they will have the same frequency. So that means this single source is termed as 2 coherent sources. Again, now we know that these wavelets will travel in the forward direction. After that, now these wavelets, they will travel in the forward direction. According to Huygens principle, each point on this secondary wavelets, here that will act as a source of the next secondary wavelets. So each point on this wavefront, that will act as a source of secondary wavelets. Then these secondary wavelets, they will overlap on each other. After the overlapping, there occur interference. So there we will get the interference pattern. Now this interference pattern, that can be of 2 types. Either there occur constructive interference or there occur destructive interference. Now for the constructive interference, we know that for the constructive interference pattern, when the two wavelets, they will superimpose on each other with the same frequency and the same wavelength. Now from the source, if this is a wavelet coming out from the slit S1 and this is a wavelet which is coming out from the slit S2, now they both have the same frequency and the same wavelength. Now when in such case, when the maxima of one falls on the maxima of second and minima of second falls on minima of second, now such type of in such type of interference, when they overlap on each other, so then there will occur the constructive interference. Means when you add up these two, or for the constructive interference, so we will get resultant intensity that will be of sum of these two. So, and amplitude, if this having the amplitude A, now these both the wavelets, they will have the same amplitude because they are originating from the single source. So automatically the amplitude of this wave, that will be 2A. So that means the resultant wave, that means where the constructive interference is done. So at this case we will get a resultant wave at this point we will get the bright fringes. That means maxima is obtained. So in this case the intensity, that will be maximum. So on the screen, when there occur constructive interference, we will get maximum intensity. So both the waves will overlap each other when maxima of one falls on maxima of second. So in this case the resultant wave will have twice of the amplitude. So we will get maximum intensity that will be obtained on the screen D, on the screen this, which is at a distance D from the two slits. Now second case, there must occur destructive interference. So in the second case, when there occur destructive interference. Now destructive interference means when maxima of one falls on minima of other. So maxima of this, if this is the wavelet coming out from the slit S1 with amplitude A. So in this case, now when this maxima falls on minima of the second. So if this is the minima of second, so here it is a minima of second with minus amplitude over here. So again this is a plus amplitude and here is a minus amplitude. Now when such type of condition is there, now when they superimpose on each other, so in this case when you add up these two, so this A and A, they will cancel out. So on the resultant we will get a wave with zero intensity. The wave with zero intensity and the zero amplitude. So here the amplitude of the wave, that will be 0. So wave will 0 amplitude. So this implies we are getting a wave with 0 amplitude, means dark fringe will be formed. So this is a condition of dark, or you can say that minima. So the minimum that will be formed and the screen. So that means for the destructive interference, when maxima of one falls on minima of other, now when you sum of these two, so this will cancel out with each other. So we will get a wave with 0 amplitude, or you can say that there will form a dark, or the minima is formed with 0 amplitude. So 0 amplitude that will be formed. So this is a condition for destructive interference. Now on the screen D, so at some points we are, so if this is a screen D over here, which is at distance D from the two slits, so here there are the two slits are present which are separated by distance D. Now the light is coming from this source. Now again, when the two waves which are superimposed on each other, so on the screen we are either getting maxima or minima, maxima or minima. So that means, so on the screen there comes no intensity, maxima, again maxima, no intensity. So such type of fringes that will be formed on the screen. So that means on the screen we will get maxima, then minima, maxima and minima. Now we want to calculate the position of these maximas and minimas. How we can calculate? Because so if this is a central maxima is formed for the one constructive interference, then again minima is formed over here. Now in order to calculate the positions of maxima and minima. So where the maxima is formed and where the minima is formed, so that will be calculated, such as, now we know that. So now in this case, firstly, this is the Young's double slit experiment. Now the light is coming from here. So in this case, these are the two slits which are separated by distance d. Now the one ray that is coming from here, S1, second is coming from S2. Now we will drop a perpendicular over here. Now again this theta is formed with the slit, now with the distance between the two slits. Now you can say that if this is a point A and this is a point C and that is a point B over here. Now AC distance, that is equals to BC. So here the distance AC, that is equals to BC distance over here. What is this point over here? Now if this is S2 and that is a S1. What is S2B? So S2B, that is a path difference between the two waves over here. So S2B, that is a path difference. Now what is the meaning of path difference over here? Path difference means the wavelets or the waves which are originating from the slit S2, they have traveled the extra distance rather than the waves which are originating from the slit S1. So path difference between, this implies the waves which are originating from slit S2. Slit S2, they travel extra distance. So they travel extra distance than the waves which are originating from slit S1. So the path difference between these two, that is given as, that is equals to S2 into B. Now we want to calculate S2 into B. Here the waves are also forming an angle theta with this distance d. So that means S1 and S2, the angle between here S1 and S2 with this B. So this angle, that is equals to theta over here. So that means this theta angle is formed. So this implies with the path difference, there exists phase difference between the waves also. So that means now when the phase difference is existed between the two waves, so on the screen with one central maxima, again minima, then maxima and minima. So multiples, you can say that primary maxima and secondary maximas are get formed on the screen. So automatically as soon as the theta goes on changing. Now when the theta is changing, that means theta here is describing the phase difference over here, which is related to path difference. Now more the path difference, now if the path difference is more between the two rays, when you shift this B to B dash point, then again this theta will be changing. So if this is theta, then that will be theta dash over here. So again when the path difference is increasing, automatically the phase difference between the two waves, that is increasing over here. So if the phase difference is increasing, automatically here the formation of, you can say that the position of secondary maximas corresponding to primary maxima, or you can say that corresponding to central maxima, they will goes on increasing. So now we want to find out what is the position of central maxima and the secondary maxima. So now that can be calculated by calculating the path difference between these two waves. So here the path difference is S to B. Now we want to calculate what will be the S to B. So now in this triangle, so here the triangle formed is, so this is the S1, here is S2 and this is the B. Here this angle is theta and that is D. Now we want to calculate S to B. So what is S to B? That will be equals to S1, S2. Now what is this? So this is the cos theta over here. So we will get that is d cos theta. So the path difference between two waves, that is equals to d cos theta. Now we will take a short break over here. So till now we have studied what is the Young's double slit experiment, how the central maxima and the secondary maxima is formed on the screen. After the break, when we come back, we will study the position of central maxima and the secondary maxima and how the position of minima is correlated to the maximas.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Now before going to break, we have studied how the Young's double slit experiment is related to interference of the light, how we calculate the position of maximas and minima. Now we will study exactly calculate the position of bright maxima, central maxima, secondary maximas and then minimas fringe width, which is correlated to the difference between maximas and the minimas position. So now in the Young's double slit experiment, we know that we have been here calculate the path difference between these two waves. Now the secondary wavelets are travelling from the slit S1 and also from the S2. So at the point P, now we want to discuss at the point P whether the central maxima is formed, minima is formed or secondary maxima or minimas are formed. So for this we will firstly understand what is the interference pattern. So now again when there occur constructive interference of these two waves, then at this point the maximum will be formed, and again when there occur the destructive interference, so at the point P the minima will be formed. Now the path difference between these two rays, that is equals to d cos theta. Now if this angle is theta, again same, that angle is also theta over here. So now there occurs conditions for in order to get maximas and minimas on the screen. So first condition is that the distance d, that is a distance between the slits and the screen, that is a capital D, and small d, that is a distance between the two slits. So d, that must be very much large than d. So that means the two rays which are coming from the two slits S1 and S2, they are parallel to each other. So this is the first approximations which is applied. That means the first approximation is d is taken very much greater than small d. Second approximation is that d by lambda, that is taken very much greater than 1. So that means the angle of divergence, that is taken to be very small over here. So due to small angle of divergence means theta is small, or the small angle of divergence, that is a condition for the interference pattern to take place. This tan theta is taken approximately equals to theta. We know that when theta is small, sin theta is equals to theta and tan theta is equals to theta. So that is taken equals to lambda by 2. So corresponding to this, path difference will come lambda by d. So that will be the path difference over here. Now this is the path difference between the two waves which are meeting at a point on the screen. So that means depending upon the path difference, whether it is equals to maxima, path difference equals to maximum intensity or gives us the minimum intensity. So depending upon this, we will get the positions of maximas and minima on the screen. Also corresponding to that, bright and the dark points are formed on the screen. So first one, what will be the position of bright fringes? So bright fringes means when on the screen the maximas are get formed. So on the screen we want to calculate the points where the maximas are get formed. So if these are the maximas which are formed on the screen, now we want to calculate their position. So for this path difference, that is equals to, that must be equals to integral multiple of lambda. So that is the main condition for the interference maximas. For the interference maximas to be formed on the screen, the path difference that must be equals to n lambda, where n it can change from value 0, plus minus 1 and plus minus 2. Means if this is a condition for central maxima, so along this side n will increases, so along this side n will decreases. Means If for central maxima we will take n equals to 0, then again n equals to 1, n equals to 2 and so on. From downward condition we will get n equals to -1, -2 and so on. So n will take value from 0, plus minus 1 and plus minus 2. That means n equals to 0 means this is the condition for central maxima. So that means at center maxima will be formed. So that means now the path difference, that is equals to x d by d, that is equals to lambda. So path difference, that will become x equals to n lambda d by d. Now it will depends upon n also, so we can write it as xn, which is equals to n lambda d by d. So that means path difference for each and every n. Now put n equals to 0, then we will get central position. For n equals to 0, we will get maxima at the center point. For n equals to 1, that will is the lambda d by d. So that is the point for the, or you can say that if this is the distance over here, so that is the distance for first maxima. Then for n equals to 2, we will get the distance for the second maxima. So that according to here, and as we move in the upward direction and the downward direction, so the maximas that will be formed. Now we want to calculate whether the intensity of these maximas goes on decreasing or it will remain same. So that is the important point over here. Now the interference pattern which is obtained in the Young's double slit experiment. So if this is a central maxima over here, so corresponding to central maxima, the intensity of each and every maxima that will remain same always. So this intensity for each and every maxima, that is same as that of intensity for the central maxima. So that is not equals to, that is not goes on decreasing as we move away from the screen. So that means central maxima intensity, first maxima intensity, second maxima intensity, they will remain same always. Now why this is so? Because we know that the light waves which are originating from the two sources or the two slits. So these slits are of equal width and separated by distance d. Now the frequency of the light waves which are originating from here, they have the same frequency and same wavelength. So that's why intensity that will be same. Now this is for the nth fringe. Now if we want to calculate the distance between these two fringes, what will be the distance between these two maxima? If we want to calculate this, now for nth maxima, this is the path difference. Now for n minus 1, that will be equals to n minus 1. So put n equals to minus 1 over here. Now the fringe width or the distance between two maximas. So what is this? This is a distance between two maxima. So we will get here. So that is equals to lambda d by d. Now it does not depend upon the n. So the distance between two maxima, that will remain constant always. So this here, the distance between two maxima, that is equals to lambda d by d. Now we know that the lambda is fixed. The lambda, that is the wavelength corresponding to the given source, that is fixed. Capital D is fixed over here. Small d is fixed, that means each and every parameter is fixed. So the distance between two maxima, that is fixed over here. So that does not depend upon n. So corresponding to this, the fringe width, that is equals to beta. Fringe width means the distance between two maximas or two minimas, consecutive two maxima or two minima. So what is fringe width? It is defined as the distance between two consecutive maximas and minimas. So here in this case, that is lambda d by d over here. Now next is the position of dark fringes. So where the dark or minimas are get formed. Now we know that for the conditions for dark fringes or the minimum intensity, the path difference between the two rays, that is equals to odd multiple of lambda by 2. So that is equals to, now this is the odd multiple of lambda by 2. Now 2n is given as the even number. So that is the odd multiple of lambda by 2 over here. Again n is varying from 0, 1, 2, 3 and so on. Now the path difference, that is now when we put here n equals to 0, we will get here lambda by 2. That means the path difference, that will be lambda by 2, which is corresponding to condition for minima over here. When the path difference equals to lambda by 2, that will corresponding to minima over here. So again x lambda, on comparing the path difference, x lambda d by d, so we will get path difference equals to this one. Now again this depends upon the n, so that if for the nth dark ranges from the center, we will get, this is the path difference over here. Now again for n minus 1 ring, we will get, this is a 2n minus 1, so replace n with n minus 1. Again the fringe width, that will be equal to lambda d by d over here. So this implies the fringe width. What is fringe width? That is the distance between two consecutive maximas or minima. Now if this is the two consecutive maximas, so distance between these two maxima, that is known as fringe width beta. Again distance between two consecutive minimas, so this is the fringe width again beta. So now in both the cases, when you are plotting the dark fringes, so now maxima means these are for the bright fringes, minimas means this is for dark fringes. Now in both the cases we are getting beta, the fringe width, that is same, so that is lambda d by d. Now it is constant throughout the pattern. On the screen when we are getting the interference pattern for throughout the pattern, the distance between two consecutive maximas or two consecutive minimas, that will remains constant always. Means when you are calculating the difference between these two maximas, this will also comes beta over here. So because it does not depend upon n, it is fixed here, because lambda is fixed, that is a wavelength which is corresponding to the source, capital D, that is the distance between the two slits and the screen, so that is fixed over here. What is small d over here? This is the distance between the two slits, so all the parameters are fixed in this case, so that's why the fringe width is fixed. So the distance between two consecutive maximas, you can take any maxima in the interference pattern, or difference between the two consecutive minimas, you can take any minimas in the interference pattern, so that will remains constant always. Now next is the, what is the fringe width? So fringe width, that is the distance between two adjacent or the two consecutive bright or dark fringes, so that is called fringe width, that is fixed over here. What kind of interference pattern that is obtained in the Young's double slit experiment? So the interference pattern that is obtained here is a, this is a condition for central maxima. So at the center the maxima is obtained, means constructive interference is taken place. Again this is the position for first maxima, secondary maxima, then this is for secondary maximas. So on both the side of the screen you will get maximas are formed over here. So on both the sides maximas get formed, while these are the dark fringes over here. So this is a bright fringe, or you can say the central fringe over here, and these are the dark fringe condition over here. Now the main point is over here, the intensity of this central maxima and the maximas on both sides, that is remain same here. So here this I0, I1 and I2, they are equal to each other. Now if this is minus I1 and minus I2, so intensity of I0, that is equals to I1 equals to I2, and you can take this as on both the sides. So intensity of all the maximas, that is same, while intensity for all the minimas, that is 0 over here. So intensity for the minimas, minimum intensity is 0. So this is the Young's double slit experiment. So here we are analyzing when the light is originating from a single source and you are placing the two slits in front of this, the central maxima, and then further on maximas and minimas get formed over here with fringe width equals to lambda d by d. Now this is the Young's double slit experiment. So in this case we have studied the position of central maximas and the minimas on the both sides, and the intensity of each and every maxima is same, while the intensity of minima is 0. This topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now if you like the video, kindly like, share and subscribe the this video, and also you can press the bell icon for the future notifications.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.